All right, 6-5, Systems of Inequalities. This is our last section of our unit. All right, so our essential question is today, how are the solutions of a system of inequalities represented on a graph? You'll be able to answer that at the end of our lesson, and it's not too long, but it has, and a lot of it is review. We have actually worked with graphing inequalities before. We're just going to be adding to our knowledge today. So let's review a little before we get into it. So when we have an equation and we need to graph a line, it needs to be in like the y equals mx plus b format, all right? Or with one of our inequality symbols in here, where b is the y-intercept. Okay, and if you remember, that is where the line crosses the y-axis, and then your m is your slope, okay, and slope is rise over run. So if it's positive, it goes up, negative, it goes down, and then run, it goes to the right. Okay, so rise over run. And then because we are dealing with inequalities, okay, we have two different types of lines. We have our dashed lines, okay. Dashed lines are for less than or greater than, and then we have our solid lines, okay. That is for less than or equal to, greater than or equal to. Now, if it is on a dashed line, it is not equal to anything on that dashed line. That's important. Okay, if it's on a solid line, it is equal to that, anything on that line. Okay, again, that's important. Now, and also because we are dealing with inequalities, please remember that when you multiply, okay, or divide, multiply or divide, by a negative number, do you remember what to do? That's right, you stop and you flip your sign. Okay, that's going to be even more important today because we are, if you remember, when we graph inequalities, we shade either above or below the line, and we're going to be graphing systems, which means we're going to be graphing two of these inequalities, and where the shading overlaps is going to be our solution set. Okay, so let's get into it. So we're going to do first example. We're going to solve by graphing. Okay, now my first equation is not in that y equals mx plus b format, so we're going to isolate our y. That's really all you're doing is isolating y. So I'm going to rewrite it, x minus 2y is greater than minus 6. So to start out, we're going to subtract x from both sides. Remember that negative sign goes with the 2 behind it, so don't lose it. Minus x minus 6. All right, last step, I'm going to divide by negative 2. Oh, I'm dividing by negative. I got to flip that sign. That's important. Negative 2, negative 2. So y, flip sign, is less than, negative divided by negative is a positive. So 1/2 x plus 3. Now we can graph it. Our b is 3, and our slope, which is always attached to the x, is 1/2. Okay, so my b is 3, 1, 2, 3. Right, we always go up from the origin, 1, 2, 3. And then from that b, we're going to run our slope, which is go up 1 to the right 2. Right? And based on our symbol, we are going to have a dashed line. Okay, dashed line. So let's dash that line. All right. Now remember, if y is greater than, we shade above. If y is less than, we shade below. In this case, y is less than, so we are going to shade below. Now you're going to see me, when I first shade, I'm going to go all the way up and down, okay? All the way up and down. And then, because I want to do it a certain way in case you just have a pencil and you don't have two different colored pens or a pencil and a pen. All right, so all of this shading is just basically lines up and down. Now this one here, y is isolated. So y is less than, well, I have my m attached to my x because m is always attached to x. But what about that b? It seems to be missing, right? Or it's not there, or it's nothing. So what number symbolizes nothing? Well, 0. So I'm going to make it visible just so I can say, okay, my b is 0, so I know where my b is, and my slope is, well, it's a whole number, so I put it over 1. So that way I always remember I'm going to go to the right 1 at the very end. Okay, so my b is 0. Okay, my b is 0. And then my slope is up 3. 1, 2, 3 over 1. Okay. Now, it is a dashed line. Okay. Got our dashed line. Let's draw it. All right. We have our dashed line, and y is less than 3x. All right, if we are less than 3x, we're going to go under, okay? So I am going to shade the other way. I'm just going to start at my bottom. I'm going to go all the way up. I'm shading. Instead of going up, down, I'm going right, left, or left, right. I'm just going to go all the way up. Okay? Now, I'm going to highlight so you can see it better. Okay? I'm going to highlight where it overlaps. Okay? Where did my shading overlap? Okay, it overlapped in this region here. That means that where it overlaps, every point under this overlap is part of our solution set. Okay? There we go. Now on your assignment today, okay, what they're going to want you to do is just to leave where it's crossed, where the shading's crossed over. That's the only part you're going to leave shaded. So we would unshade this part, we would unshade this part, and we would just leave this part here shaded because that is where it crosses over. Okay? So, what is our solution set? Well, it's the double shaded area, basically. Okay, it's this double shaded area. Okay, our solution set is all these points in here. Now, what you may see the state do is the state may give you, okay, a set of coordinates, 3, 1, 0, 0, negative 1, negative 2, negative 3, 1. And it may ask you to select all of the points that are in your solution set. Okay, so 3, 1, all right, so I go back to my origin, 1, 2, 3, it's a little hard to see, 1, all right, that is in my double shaded area, yes indeed, that is part of my solution set. Now what about 0, 0? Now here's the thing, if you remember when I said it was if the point is on a dashed line, it's not part of our solution set. 0, 0 was our B, so it is on our dashed line, so 0, 0 is not part of our solution set. What about negative 1, negative 2? Oh, well, depending on how accurate you are, it's either on or above your dashed line. So therefore, no, it is also not part of your solution set. And -3, 1, 2, 3, 1. That's right there. That is definitely not part of your solution set. So that could be one of the ways that the state tests you on this skill, okay? It'll give you a systems of inequalities, and it'll ask you, what are your possible? It'll give you a couple of different choices and ask you to check, pick your possible solutions, okay? May or may not have a graph. You may have to create the graph. You do get graph paper on your EOC. All right, so let's practice that skill again. Okay, let's practice that skill again. All right, this has y isolated and mx plus b, all right? It's just flipped backwards from what we're used to seeing. So if you want to flip the entire equation, so it looks like the standard form we are used to, you also have to flip the sign if you're flipping the equation. Because remember my original equation, the larger part of this inequality is facing towards the y. So the larger part of the inequality sign has to face towards the y. Okay, and then you can write your m, x, and your b. So m is 1/3, b is 2. So b is 2. All right, m is 1/3, so you go up 1 to the right, 1, 2, 3. And we are a dashed line. Okay, we are a dashed line. All right, and y is greater than. So remember, if y is greater than, you're going to shade in above the line. All right. So we're shading in above this line. Okay. Now, these types of lines are still giving my students a little problem. Okay, these are not in the y equals mx plus b format. There's no y in here at all. It's just telling me that x is greater than or equal to -3. Well, if it's literally telling you x is greater than, equal to, if it's saying x on one side and a number on the other, you actually need to find your x-axis and find that number on that line. Okay, so -3, 1, 2, 3. And if x is on one side and a number is on another, this is a vertical line. Okay, straight up and down. And we are a solid line. Okay, so we're going to draw a solid line straight up and down. All right. Let's draw a little thicker, just so you can see it a little better. There we go. Okay. A little thicker. All right. Now, if x is greater than or equal to -3, we have to shade to the right. All right, we have to shade to the right if x is greater than or equal to. All right. I'm getting there eventually, shading the whole thing. All right. Now, I'm going to highlight where our shading crossed over. All right, and everything under this highlighted area, this is considered your solution set. Okay. So again, on your assignment, you would then leave this blank and just have this here shaded in. Okay. Also, you will notice a new feature. You have to draw a solid line first, and then there's another button that goes from solid to dashed lines. And so after you draw the solid line, you hit that button and you hover over the solid line that you want to turn dashed. It will change to like a yellow color, and you can click on it and then it will dash your line for you. Okay, so I just want to make sure you know how to do that. All right, so our solution is all, so the solution set again, equals that double shaded area. All right, so let's try a couple again. So 0, 0, is 0, 0 part of our solution set? Nope, sure not. What about 1, 5? Is 1, 5 part of our solution set? Let's see, 1, 1, 2, 3, 4, 5, sure is. Okay, so any of the points that are in here in an XY fashion is part of your solution set, okay? One of them is going to ask you to type in, and you're just going to pick a point. You're going to go, okay, I pick that point where the double shading is. Okay, well, what's the address of that point in XY fashion? Okay, that's all it's asking for. So we've done it twice where we have a solution set where we have that double shaded area. Now let's look at what it looks like when we solve by graphing and there's no solution. Now remember, with flipping signs and everything and shading above, below, you do need to be very careful with these, okay? Because these are going to be very particular types of lines, but not all of these particular type of lines are always going to be no solution, okay, when you have inequalities. So let's take this first one, not isolated y, so minus 3x plus 4y is greater than 0. First step, we're going to add 3x to both sides. 4y is greater than 3x plus 0. I'm leaving that 0 in as a placeholder, so I have a b. All right, so I don't have to think about it. All right, so y is greater than 3/4 x plus 0. My m is 3/4, my b is 0. So my b is 0. And my slope is 3/4. So 1, 2, 3. 1, 2, 3, 4. All right, we have a dashed line. Okay, a dashed line. Okay, and y is greater than, so we are going to shade above. We're going to shade above. All right, now let's do our other equation. We need to isolate this y. Okay, so 3x minus 4y is greater than or equal to 8. Isolate our y. So we're going to subtract 3x from both sides. Remember that negative is attached to that 4. Minus 3x plus 8. Going to divide by negative 4. Oops, if I'm dividing by a negative, I must change the sign. Now the reason why I put that little, I don't know, shape around my sign is so that when I go through, I will flip my sign. I don't forget, okay? So y, I'm flipping my sign. Negative divided by negative is a positive. X minus 2. Okay, so my m is 3/4. My b is negative 2. So negative 2. My b is 3/4. 1, 2, 3. 1, 2, 3, 4. I have a solid line. Now I have parallel lines, okay? So I have parallel lines. Now I did flip my sign, so y is less than or equal to, so if it's less than, we have to go below. All right, and does my shading area cross? No, it doesn't, so this is no solution. Now, no solution. Now, when you are dealing with systems of equations, of linear equations, this would always be a no solution. But because they're parallel lines, they don't cross. But with inequalities, we talk about shading crossing. So these could still have a solution set if, let's say, we were to shade under the blue one, it would cross right here. Let's say we shaded above the pink one. All right, then it would cross up here. Now, if we shaded below the blue one and above the pink one, and then in between the parallel lines would be your solution set. Okay, so with our inequalities, even though they're parallel lines, you could still have a solution set if you have overlapping shading. All right, your assignment is in Alex. It's not that long because, these do take a little while. You do need to make a minimum of an 80 and to show your work, okay, show your work. Because it is an Alex, everyone has some different numbers and different graphs they have to make. All right, if y is isolated, you just have to write the equation. If it is not isolated, to show your work, you're going to show me that you isolated it, okay? So that's what I want to see on your paper. To see the work is to see that, yes, okay, I did isolate that y. All right, so I have this equation down. I've done my work. That's the work I want to see. All right, but again, if y is already isolated, you don't have to, unless, y is on the wrong side and you want it on the left. So other than that, good luck.